Kaboom! One huge asteroid could be enough to wipe out all dinosaurs that ever roamed the Earth, leaving behind nothing but a huge crater. Yeah, we're in the Yucatan Peninsula, Mexico, and underneath there's Chicxulub, a massive crater. Now, if there's this immense hole, there must be a meteor too, right? Well, weirdly, no one has ever seen the actual remnants of the space rock itself. It's a bit weird, especially considering how important it is. After all, many think the same meteor that created the crater is the one that wiped out dinosaurs. Now, it might have vaporized on impact, creating a massive explosion. Most of the meteor could have turned into gas or tiny fragments scattered across the atmosphere. Or it might still be here, on Earth, just hiding. And scientists have finally discovered where to look for it. But it's not easy to reach. Around 66 million years ago, a giant asteroid went down and marked the end of the Cretaceous period. It slammed into what's now called Mexico, just north of Central America. The explosion from the impact triggered a global heat wave, which was followed by years of winter. It threw Earth into total chaos. The consequences of this catastrophe led to the extinction of more than 60% of life on Earth, including all the non-avian dinosaurs like T-Rex and Triceratops. It also took down flying reptiles, pterosaurs, and sea creatures like mosasaurs. Long story short, it was the end of the dinosaurs era. But don't be too sad about it, because it paved the way for the rise of mammals and you and me. Anyway, scientists have recently figured out where the infamous asteroid came from and where it ended up. The thing wasn't just wandering around Earth's neighborhood. This massive rock might have formed beyond Jupiter and headed straight for our planet. But we'll talk about that a bit later. First, let's look more closely at the collision that created the Chicxulub crater. When the asteroid slammed into Earth, rocks from deep within the planet's crust were thrown up to 15.5 miles into the sky. It also created mountains taller than the Himalayas around the crater's edge. The asteroid itself, called the Chicxulub impactor, was about 6 to 9 miles in diameter. It hit Earth at a speed of around 12 miles per second, coming in at a 60-degree angle. I know we're not in a geometry class, but the angle is important here, since it was exactly right to send the maximum amount of vaporized rock into the atmosphere. As a result, massive plumes of sulfur gases and fine dust shot up, blocking out the sun and causing what's known as an impact winter, which lasted about 15 years. At the time, dinosaurs reigned on Earth. They'd been around for nearly 200 million years before the catastrophe led to their disappearance. The meteor theory seems all plausible, and all the facts add up, but even now, not everyone agrees with that. Some believe that dinosaurs were already on the brink of extinction before the asteroid impact, and the collision might have just sped up the process. Anyway, most dinosaurs were wiped out, but if scientists are right, then those who somehow managed to survive were the ancestors of modern-day birds. So we have an idea of what might have happened, but it took years of studies. The crater was first identified by scientists working for Pemex, a Mexican oil company, in the 1970s. And sometime later, scientists finally realized the mass extinction event that ended the Cretaceous period was because of the Chicxulub. One piece of evidence that pointed to the asteroid were the local fish back then. You see, when the asteroid struck, the immense force of the impact reshaped the planet's surface. For example, it turned rocks into glass-like spherules. Now, spherules are like small spherical particles that can form from the rapid cooling of molten silica droplets. And some of these spherules ended up in the gills of fish that were wiped out by the impact. So, when during another research, scientists studied these fossils, it became obvious to them that the asteroid strike had happened during springtime in the northern hemisphere. They figured this out by studying the lines of growth in the fish's bones. Yep, those can be read just like tree rings. Of course, throughout many years, researchers continued exploring the impact site, hoping to find new data about the catastrophe. Their best bet was to turn to the chemical record left behind by the asteroid, the debris of which is hiding under all those layers of rock and sediment under the Yucatan Peninsula. So they studied the chemical signatures in rocks from the end of the Cretaceous period and found that the asteroid came from beyond Jupiter. And it wasn't just any asteroid, no, it was a carbonaceous chondrite, one of the oldest types of asteroids in the solar system. It most likely formed billions of years ago. These types of asteroids only come from the region beyond Jupiter. So the asteroid that caused the extinction event must have originated there. One of the main clues was ruthenium. It's a rare element in Earth's rocks, but much more common in asteroids. Scientists detected tiny amounts of ruthenium in the rocks, which helped them confirm that the asteroid came from outer space, not from a comet or volcanic eruptions. In 2016, scientists also published the first results from a drilling expedition into the Chicxulub crater. The team managed to drill more than 4,000 feet beneath the seafloor, getting their hands on core samples containing pieces of the original granite bedrock that was struck by the asteroid. These rocks are deeply shocked and placed out of order on top of sedimentary layers. It supports the theory that the peak ring of the Chicxulub crater formed through a dynamic collapse process. Now, about that peak ring. Scientists specifically targeted it in their exploration. The so-called ring is a circular ridge inside the crater rim. Similar peak rings can be found in the largest impact craters in our solar system, on the Moon, Mars, and Mercury. But on Earth, Chicxulub is the only well-preserved crater with a peak ring. This discovery also aligns with recent findings from NASA's lunar mission. It showed that the peak rings within the Orientale impact basin on the Moon had formed in an equivalent way to those at Chicxulub. The team is so eager to study the peak ring because they want to test their models of crater formation. Plus, they hope to find out whether this area could have been one of the first habitats for microbial life after the asteroid impact that wiped out dinosaurs. The peak ring formed just minutes after the impact. The deep granite bedrock, initially flowing like a liquid, rebounded into a central tower as tall as 6 miles before collapsing into the ridge we see today. This was followed by a layer of breccia. That's a jumble of rocks and impact melt. And after that, ocean tsunamis brought massive amounts of sandy sediment into the crater. Another find from 2016 was a 10-foot-long core, which revealed bits of granite and minerals from hot, fluid-filled cracks. That was a sign that they had finally entered the peak ring. Geophysicists from the University of Texas explained that they had expected the peak ring to be a large hydrothermal system, and they were drilling to confirm this. The team eventually reached deeper layers, drilling down to 4,380 feet. The team was able to collect most of the core samples they hoped to get, and the samples they got were in great shape. They also gathered lots of useful data from the early Paleocene period and completed a successful scan of the drill hole. Now, scientists from around the world will need some time to fully study and understand what these findings mean. But they're sure that this mission will help answer some big questions, like what exactly happened when the asteroid hit, how it wiped out the dinosaurs, and how impacts like that affect life deep underground.
Whoosh! Debris runs through outer space all the time, often heading towards our planet. We're mostly not aware of it. Most of that debris burns up when it enters our atmosphere anyway. We do get to enjoy the bright blaze in the clear night sky because, from time to time, we see it as fleeting meteor showers. But sometimes, a meteorite is tough enough to survive the atmosphere and large enough to leave a remarkable spot on our planet. We're talking about what often looks like nearly circular excavated holes. Nestled in the Colorado Plateau in northern Arizona, Barringer Crater is a rimmed pit in the shape of a bowl we also call Meteor Crater. It's relatively young since it formed only 50,000 years ago. There was this enormous iron meteor that hit at eye-watering speeds of up to 26,000 miles per hour. It exploded so hard that the meteorite excavated an amazing 175 million tons of rock. Daniel M. Barringer first identified this crater. He strongly believed the pit was a result of a meteor hitting our planet, but not many scientists believed him. Barringer spent a couple of years investigating this crater to prove his theory. Not just that, he also hoped to find some of the valuable metal content, but a major part of this once pretty large meteorite would have been destroyed during the collision. Kali Crater. At first, it seems like you're looking at a nice swimming pool, but 7,500 years ago, another meteorite headed towards the Earth. While passing by through our planet's atmosphere, it fell apart and hit our planet in fragments. That's how Kali Meteorite Crater Field formed. A group of 9 meteorite craters in the Estonian village of Kali. That's located on one of the country's islands. The largest crater ended up being 360 feet wide and 72 feet deep. The rest of the 8 smaller holes are located right around the main one. It's a tourist attraction today. But imagine how panicked our prehistoric ancestors that lived there must have felt while watching these gigantic rocks fall from the sky. Also, there's a chance the surface of this island was covered in forest, but it all probably burned down during the impact. South Africa has its own gem too, Vredefort Crater, the largest and the oldest one in the world. More than 2 billion years ago, a meteorite with a diameter of 6 miles struck our planet close to today's Johannesburg, South Africa. This impact was nearly twice as powerful as the one that made the dinosaurs go extinct. Almost right after the meteorite hit the ground, the crater formed. The hole shallowed and widened as the rock below began to rebound, plus its walls collapsed. The meteorite that hit this spot was probably 6 to 9 miles in diameter. If a celestial object that hit the Earth is bigger than 0.6 miles, it could have effects on the global level. So this one probably caused fires across the world. Also, enormous amounts of dust probably ended up in the atmosphere, which changed the climate for months, maybe even years. Lonar Crater is an astonishing spot in southern India, discovered almost 200 years ago. The pit lies within a large plain of basaltic rock left over from violent volcanic eruptions in this area, which happened 65 million years ago. Scientists even thought it was a volcanic crater at first, but soon they realized it was the result of a strong meteor impact up to 50,000 years ago. Look how specific basaltic rock is. And Lonar Crater is the only one formed in such a type of rock. There are trees all across the lower crater hills. And you can find a couple of interesting species over there, such as chinkra, peafowl, and gazelles. Plus, you can see many migratory birds flocking to the lake in the cold winter months. Yup, there's a lake there, and it's both alkaline and saline. In 2020, it surprised the local people because it changed its color to a rosy pink. It seemed unusual at first, but then scientists discovered such a specific color was the result of a growing population of a specific type of salt-loving microscopic organisms that produce such a pink pigment. This place is important for Indian mythology too, which is why there are multiple temples around the edge of the crater. Here's something really remarkable. The Rias crater contains an entire town within its inner ring. It's a small town in Germany. You can see the full result of this impact only from the air. The town walls highlight the inner ring of this crater that's about 0.6 miles, 1 kilometer, in diameter. Those are probably the dimensions of the meteorite that formed the crater. You can't distinguish the rest of it so easily, since the crater has been eroded away. That means natural forces such as rain and winds have changed it. In the heart of the Ungava Plateau lies the amazing Pingualuit Crater. The crater has its own pristine rainwater, some of the purest water you could find. It's not in any way linked to other lakes in that area, nor does it receive water from them. The water there accumulates from snow and rain. It's only lost when it evaporates. The depth of almost 900 feet is like a window to the crater's rich geological past. Scientists found different elements such as cobalt, nickel, and iron that helped them determine it was a specific type of meteorite where its parent body hadn't modified it in any way. The parent body is the celestial body from which a single meteorite or an entire class of them originate. Pingualuit crater formed over 1 million years ago. There are even traces of stone set in a circular arrangement and rock shelters. People that used to live in this area would set up camps on the ridges of the crater. It was a good position for them to catch animals and stay safe at the same time. Australia is home to some of the world's most fascinating impact craters. In its western part, you can find the massive Wolf Creek crater. It's the world's second largest crater that lies on the edge of the Great Sandy Desert. More than 100,000 years ago, one meteor was most likely traveling at crazy speeds of 10 miles per second before finally slamming into the desert. Scientists discovered it in the middle of the 20th century, but local people had known about it long before that. They had many cultural stories about that crater. One was about two ancestral snakes who were so incredibly big they managed to form both Wolf and the nearby Sturt Creeks as they were making their way across the desert. One of those giants emerged from the ground, and that's where the big crater is today. It's dangerous to climb there since rocks are pretty loose, but that's where you can see some interesting animals like brown ring-tailed dragon lizards catching insects for lunch, or Major Mitchell's cockatoo harvesting seeds from the plants that grow on the crater floor. Another must-see crater in Australia is Goss's Bluff. It lies in the heart of the continent, sandwiched between the James Range and the McDonnell Range. It's a place of great cultural importance, so if you're visiting, respect signs stating which areas you're not allowed to access. A giant meteor slammed into our planet more than 140 million years ago. It was a really long time ago, so the original crater has been eroded through time. But even today, you can still see its core. A central ring of hills nearly 3 miles in diameter. This looks like you're on Mars, doesn't it? It's actually southwestern Algeria, and its famous Amguid crater. This one is relatively young, considering it's a result of a meteor impact that happened 100,000 years ago. This crater has an almost perfectly circular shape. Its center is unusually flat because of the type of soil at the bottom and the fact it's tightly compacted.
Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, but even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet. even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66-million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, they could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. Other life forms survived too. Fungi and mold survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape. After a few thousand years, forests started to reappear. The animals that survived were pretty much all inconspicuous and small creatures. They lived in burrows, safe from all that hot ash. Before the collision, mammals had lived in the shadow of dinosaurs. But with all the dinosaurs suddenly gone, things were about to change. Mammals were able to take over. They began to dominate life, at least on land. Back to the moment when everything changed. Turns out, it wasn't the size of the asteroid that made it so powerful. It was more about the angle in which it hit the Earth. If the angle of impact had been different, the dinosaurs might have even survived the catastrophe. So, what would that have looked like? Well, let's travel back, way back. Oh no, there's a giant asteroid heading for Earth. Oh, wait, never mind, it missed. Whew. There are plenty of earthquakes, tsunamis, and volcanic eruptions every day, but dinosaurs don't mind that much. No big deal. Fast forward a few million years, and most of these ancient lizards have changed and are now unrecognizable. Thanks to a couple of ice ages, many dinosaurs are now totally covered with feathers to protect them from the cold. Mammals exist, but they're few and far between. You see a lot of bats in caves. There are tons of rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, no elephants, or other large mammals. Why become large and eatable when there are so many dangerous reptiles with huge fangs around? There are no whales in the sea. Parrots, hawks, and pigeons are nowhere to be seen. But pterodactyls 2.0 whiz past you constantly. Some are about the size of a helicopter, while others are no larger than a swan. There are plenty of primates, but they're in no hurry to climb down from their trees and walk on two legs. No venturing out into the savannah, no evolution into Homo sapiens. In this alternate reality, open spaces are very dangerous. But then again, so are forests and trees. Nowhere is safe. To get some delicious primate treats, many smaller dinosaurs learned to climb trees. This was already happening back in the Cretaceous period, right before that huge asteroid just missed Earth. Whew, that would have been an epic collision. Dinosaurs have grown wiser since that near miss. Some are even as smart as a modern chicken. A large brain uses a lot of energy, and that's not always a good strategy for survival. Safer to keep brains small and keep making those teeth bigger and pointier. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.